Chapter 2, Getting Started to Coding. Learning objectives. At the end of the chapter, students would be in a position to write codes in Python. To start a coding project, you don't just start by immediately writing something in a coding language. You first need to work out what you are doing and what it needs to do. Like with the putting the kettle on flowchart. Process of writing code. First, define the goal. Second, decide what it needs to do. Flowchart, pseudocodes, etc. Third, code each step. Pseudocode is writing out what code will do step by step, but in regular language rather than a coding language. When you do step 2 and design those instructions, you are creating an algorithm. An algorithm is a precise set of instructions that describes an activity in a way that is repeatable. They can be represented in various ways, such as in pseudocode, a flowchart, or using symbols. You might have heard about algorithms more widely, and they are often painted as something to be blamed. However, an algorithm is just the set of instructions for how something should be done, whether in code or otherwise, and has to be designed by someone. Once you turn that algorithm into computer code in step 3, you have written a program. The code cells in this book is written in Python, a common programming language used because it is versatile and good for beginners. Python is a coding language used for a wide range of things, including working with data, building systems and software, and even creating games. A quick recap from chapter 1. Variables are how you can store values in the computer's memory to work with in your Python code. A variable is given a name and a value. You can then use the variable by referencing its name and change the value if needed. Hence, it is variable or can vary. Variables have different data types depending on what kind of information they store. This allows the computer to know what kind of actions can be done with that information. For example, whether or not you can do arithmetic with it. To create a variable in Python, you just need to give it a name by typing 1. Then use an equal sign to assign it a value. Variable names in Python can only start with either a letter or an underscore, and they cannot include any spaces. There are many different data types in Python, but here are some useful ones to start with. Strings. Some characters such as letters, symbols or numbers which are treated as text, they must be surrounded by either single or double quote marks. Integers. Positive or negative whole numbers. Floats. Floating point numbers shortened to float are decimal numbers, either positive or negative. Booleans. The Boolean data type is data that is either true or false. It can be shortened to bool. Lists. Lists allow you to put multiple values together in one variable, separated by commas, so you can access them as a group or individually. As mentioned above, lists in Python are a way of storing multiple separate values in one variable. This means you can work with the whole collection as well as individual items by accessing them using an index number or position in the list. Lists are stored in a particular order, which can have duplicate values, and to which you can add, remove, and reorder values. Lists must be written in square brackets with each value separated by a comma. Items in a list can be different data types like strings, numbers, or even another lists. Python list indexes start from 0. So to access the first item in the list with the name mylist, you would use mylist 0. To access to second item, you did use mylist 1, etc. Operators are the Python commands you use to do things with values whether or not they are stored in a variable. They are mostly represented by punctuation characters, though some of their meanings might not be what you did expect. Assignment operators can use to assign values to variables. The equal sign is most common as it is used to assign a value to a variable either when creating it or when changing the value. You might also use equal to plus to increment a variable's value by 1 and assign it that new value. Arithmetic operators are used to do mathematical calculations like plus, minus, divide. Comparison operators are used to compare values. Example, when making decisions, so you might use to compare if two values are equal, to compare if values are not equal, or the greater or less than symbols for checking which value is greater. Logical operators are used to combine statements when making decisions in code using keywords like and, or, and not. Comments are crucial in any coding language as a way of explaining to yourself and others what your code is doing, adding important notes and translating your pseudocode notes into actual code. In Python, you tell the computer to ignore a line or the rest of a line by using a hash symbol. Once the computer reaches a hash, it will know the rest of the line in a comment, not code to be executed, and will skip ahead to the next line. Use comments to note what parts of your code do or to add information that you or someone else might find useful in the future. Comments are also a way of stopping a line or lines of coding running whilst you test or try and troubleshoot it. Adding a hash to the start of a line of code will mean it will not run. Loops are used in Python to repeat code multiple times, either for a particular set of values or while a statement remains true. So this might be for a particular list of values, like some names, or until a changing numerical variable is above or below a certain value. This means there are two kinds of loops, for loops and while loops. And you are emphasizing those words because they are how you create these loops. The for keyword in Python is how you start a for loop. If you are doing to loop through a Python list, you then create a variable that stands for the individual values in that list. Then use the keyword in. Then finish with the name of the list in question and a colon. So you will end with something like for item in shopping list, where shopping list is a list variable you have already created. The while keyword creates a while loop, which means that instead of running through values in turn, the loop returns to evaluate a condition each time the code runs to check whether it should still be running. This makes while loops useful if you don't know when the loop will need to stop, but want the code to make that decision based on the condition you give. A while loop is created by starting with while, then defining a condition to be tested each time, and ending the line with a colon. Note, in Python, all the code inside the loop after the colon must be indented, as this tells the computer which code is in the loop. Once the indentation ends, that is the end of the loop. As well as automating repetition, Python can be useful for also automating whether or not certain codes should run. By giving the computer a statement to evaluate, you can make it decide whether or not the subsequent code should run using an if condition. The statement can be evaluated to either true or false, and a true statement will make the code run. There are multiple levels you can have to an if condition. On the most basic level, you can just give one option to run some code if the statement is true, or skip past the code without an alternative, it is false. Or you can offer an else as well. Code that runs if the statement was false. You can also add extra statements that could be true into your condition using elif, short for else if. Like a loop, you start an if condition with a keyword. In this case, the if keyword. You then write your condition to be evaluated within brackets and then end the line with a colon. As with loops, any code that should happen if the code is true needs to be indented to show the computer which code is inside the condition. A simple if condition might look like: Python has a range of commands built in, but as Python is used for a huge range of things, there are also many more commands that people have created to make it easier to do particular tasks in Python. These commands can be part of libraries, which are packages of Python code and files that will allow you to use these commands. That code is often called a module. You can create your own modules to put together functions that can be reused. Some of these packages of code can be imported straight into your Python code, and others have to be downloaded and added before imported. One way of doing that is using a tool called PIP. Your first code, output, hello world. What did that do? Let's look at each line in turn. The first line begins with a hash symbol, which in Python is how you mark something as a comment. That means the computer does not read the rest of the line, but we humans can. Line 2 is empty. In coding, it can be useful to leave empty lines to help you separate out code and read through it more easily. The computer does not care. Line 3 has two parts, the print part and the hello world part. The first part is a statement that tells the computer to print whatever is inside the brackets into the screen. The second part is what you want to be printed. Why the quotation marks? Because the thing we want to print, hello world, is a string. And the string data type in Python needs to be surrounded by single or double quotes.